Okay, so, hold on, I'm turning my mic around because it's going to go from the board. Okay, so, today we're going to not be in our composition book for the first part. We're just going to make sure you understand where the ordered pairs we're going to put on the unit circle are coming from. So, first of all, this is the unit circle, so this is the origin, so this is the point 0, 0. Let's not use that color. Alright, so we know this is 0, 0. We know that the radius is 1. So this is 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Alright, so just to go back and put where our pi over 4s are, where every 45 degrees go. So, I'm going to erase all of this because I need it to be drawn, to draw in pictures. Okay, so we're going to do these 4 all at the same time because they're all kind of similar to each other. So, if I draw in a triangle, this is a right angle because I came straight down vertical to that horizontal axis. Alright, so we know this is a 45-degree angle. So you remember back to geometry. You know that a 45, 45, 90 triangle has these side relationships. You may not remember that, and we're not getting into why. Just know that it happens. So these two sides are the same, and this side is x squared 2. And you can use the Pythagorean theorem to figure that out. But again, we're not going to worry with all of that. What I know is that these are the same. And this is supposed to be x root 2. But what I know, since it's the unit circle, is this is the radius of my circle, so this is 1. So if hold on. Okay, so we have x squared plus x squared is equal to 1. So we know 2x squared is equal to 1. So we know x squared is equal to 1/2. So taking the square root of that, we have 1 over root 2. And then you have to rationalize. Now, I'm showing you all of this so you know where these come from. It's also a lot of things that kind of requires you to remember some things that you've learned before. So, recapping. I know that the radius of my circle is 1. And from the Pythagorean theorem, if I just call these both x, because I know they're the same, then we have x squared plus x squared equals 1. So 2x squared, divide by 2, take the square root. You should be okay up to there. You have to rationalize the denominator, so multiply the top and the bottom by the radical in the bottom. And you get root 2 over 2. So both of these measure the square root of 2 over 2. So if I'm going from the origin to this point, remember that's an x value or y value. So there's an ordered pair of root 2 over 2, root 2 over 2. Alright, well if I think about what's happening over here, you're getting the exact same triangle. You're just going negative, positive. So this is negative root 2 over 2, positive root 2 over 2. Alright, if I come down here, it's the exact same triangle. We're going negative, negative. So negative root 2 over 2, negative root 2 over 2. And if I come over here, again, exact same triangle. We're going positive, negative. So it's positive root 2 over 2, negative root 2 over 2. Alright, so next. We have these guys that are 6. So like 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. Those we count around our unit circle. Or like 30, 60, 90. Alright, so let's just do this one for now. Alright, so same concept. I know this is 1. Alright, and I know that we have this relationship. Alright, whatever the short side is, the hypotenuse is double that. Alright, well, if this is 1, and it's supposed to be double the short side, that means the short side has to be a half. because 1/2 times 2 is 1. Alright, and then here you have x root 3. Well, the short side is x, so that is x root 3. I'm going to do 1/2 times the square root of 3, which gives me the square root of 3 over 2. So 1/2 times the square root of 3 is the square root of 3 over 2. Alright, so again, I said this was half because this relationship says that the hypotenuse is double the short side. And then I got root 3 over 2 because this relationship says the short side times root 3 is going to give me the long side. The longer leg, but not the longest side, which is the hypotenuse. Okay, so x is root 3 over 2, y is 1/2. Alright, so same concept. This is the same triangle. I just go backwards and up. So negative, positive. So negative root 3 over 2, 1/2. Same triangle happening here. But it's negative, negative. So negative root 3 over 2, negative 1/2. And then same triangle here. Positive, negative. So positive root 3 over 2, negative 1/2. So they all four have the same ordered pair. The ones close to the x-axis all have the same ordered pair. The signs are different depending on the quadrant that you're in. All right. So let me clean this up. And we're going to do the big ones. So this guy is the same triangle you just had here. He's just turned. So we know this is 1. The short side, because this is a 60, which means that's 30. So we still have a 30, 60, 90 triangle. So the short side is a half, the long side is root 3 over 2, the same way that we just played it out a minute ago. Alright, so we have an x of 1/2, a y of root 3 over 2. Over here, we have a negative x and the positive y. Down here, they're both negative. And over here, it's positive x, negative y. Alright, so print you a practice unit circle, fill in degrees, fill in radians, and then check, and then you can fill in the ordered pairs with me. Okay, so pause, do your practice unit circle, unpause, watch and see how you did. Alright, so degrees, we got 0, 30, not 60, sorry, 45, 60, 90, 120, 135, sorry, I just froze, 150, 180, that's an 8, 210, 225, 240, 270, 310. Sorry, these are kind of all over the place. That's literally not 310. What did I just say? 310 is not on the unit circle. Sorry, 300, 315, 330, and 360. I struggled a little too hard with that, sorry. It's the first time I filled out this particular unit circle. Remember, this is Sunday before I've taught any of this. And I forgot that these are all jacked up. Alright, so on your radians, you should have 0 radians here, so you should have a 0. And we have pi over 6, pi over 4, pi over 3, pi over 2. Then 2 pi over 3. Alright, so the way that I think that you should try to do this is just do the 6. So 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. 6, 6, 7, 6, 8, 6, which reduces, 9, 6, which reduces, 10, 6, which reduces, 11, 6, and then 2 pi. And then you can go back and do your 45s, which are fourths. So 1/4, 2/4, 3/4, 4/4, which is 1 pi, 5/4, 6/4, which is 3/2, and 7/4. If you can go all the way around the circle and not do the counting by 6 and counting by 4s, then that's really great. But if you have to count it like this, it's fine. You'll get it right. Okay, so ordered pairs. So first of all, the quadrantals we've known since day 1. All right, and then this is how I think about it. Right here, I'm big X, little y. When you're filling in ordered pairs, you have big, medium, little. All right, so big X, little y, so root 3 over 2, 1/2. And then this is the same, but negative, positive. This is the same, but negative, negative. And this is the same, but positive, negative. All right, in the middle, you're like medium because they're matching. So this and this are the same. So root 2 over 2, root 2 over 2. So this one is the same, but negative, positive. This one is the same, but negative, negative. And then this one is positive, negative. All right, and to get this one up here at 60, it's little x, big Y. And then these guys are going to match, but the signs change depending on the quadrant you're in. All right, so the other day we put the unit circle in your composition book, and I told you that you could go ahead and put the ordered pairs on if you were watching the video, or you could wait. So if you didn't do it then, go back and put the ordered pairs on that unit circle. I think that is all. This is just there to remind you that when you are taking the unit circle test, you're going to have to know these definitions. So make sure those are in the composition book. Make sure that you are studying those. And then this is something that we're going to put in our composition book. So in your composition book where you left off, you have this information. Let me see if I can switch to my document camera and look at your composition book. Hold on. It's wanting to use this one too much. Again, hang on, see if I can make it work. Okay. Alright, so again, at the beginning of your composition book, you have those definitions at the beginning of chapter 4. That's what we started with. You need to know those, and you need to know this information, which is what we're fixing to learn. You have this unit circle glued in your composition book if you printed it. So fill in your ordered pairs. Alright, and then where we left off at the end of 4.1, go to the next page, and we're going to do 4.2. Alright, so for 4.2, we have this little thing to glue in. And it's just the definition of your sine, cosine, tangent based off of the unit circle. So you should have learned the SOHCAHTOA, and if you did, then if you're looking at a right triangle, then if this is my angle, sine is opposite over hypotenuse. But if we're in the unit circle, the hypotenuse is always going to be 1 because the radius of the circle is 1. Pretend like that actually works. Alright, so from your angle, sine is the opposite, which is going to be the y value, because you're going to go x, y to get to this point. Alright, so if the radius is 1, then sine is opposite over hypotenuse, so just y over 1, so just y. Cosine is adjacent over hypotenuse, so just the x. Alright, so at this point, you just need to know sine is the y, cosine is the x, tangent is y over x. And then cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. Alright, so if you have a unit circle handy, that will help, because right now we're going to do one practice problem doing this with things from the unit circle. And then we'll pick up doing more of these when we come back from fall break. Alright, so if I just give you that we want to look at pi over 6. So the first thing you're going to do is, do I know the ordered pair at pi over 6? So right now you can go look it up on your unit circle, but by the time you take this test, your unit circle is supposed to be in your brain. And so you're going to close your eyes and say pi over 6, big X, little y, so root 3 over 2, 1/2. So root 3 over 2 is the X, 1/2 is the y. So sine is the y, cosine is the X, tangent, you have to do y over x. So for y over x, that's 1/2 over root 3 over 2. So I'm going to work this way. So that means we have 1/2 times 2 over root 3, which means we have 1 over root 3, which then has to be rationalized and becomes root 3 over 3. Alright, for cosecant, you're going to do the reciprocal of sine, so it becomes 2. For secant, you do the reciprocal of cosine. I'm really tired, sorry. Secant is the reciprocal of cosine. So you take root 3 over 2 and you flip it, you get 2 over root 3. Alright, so if I have 2 over root 3, then I have to rationalize and multiply the top and the bottom by the radical on the bottom. And you get that. Alright, and then for tangent, or for cotangent, it's the reciprocal of tangent. But be smart. If I flip this, I got a radical on the bottom. But if I take this thing before I rationalize it and I flip it, I just get my root 3 back. So you can flip it at this point before you rationalize. Okay, so that's all we're going to be doing on Friday. We may do more examples. It depends on how much time we have. I honestly don't know how many examples we're going to get through, how far we're going to go on Friday. If we end up going farther than this on Friday, then I'll put a separate video in Friday afternoon before I leave school that has the rest of what we covered. But for now, I think this is my plan on where we're going to stop, because I have 2 days planned. I plan on doing 4-2 again when we come back. And the rest of this would be that day. So like some review and the rest of this. So I think this is where we're going to stop, just with that one example of that. Actually, hold on. I'm going to pause the video and look it up, and then Okay, this is where I stopped the last time I taught this, so I think that's probably all we're going to have time for on Friday. So again, like always, please let me know if you have questions. At this point, when you practice your unit circle, you need to be practicing degrees, radians, ordered pairs, and making sure you know the definitions. So practice all of those. And that's the only homework that you have, is to do a practice unit circle with everything. All right, please let me know if you have questions.